The question is that if A, comma B, comma C, comma D are in GP, we have to prove that the A raised to the power n plus B raised to the power n, comma B raised to the power n plus C raised to the power n, comma C raised to the power n plus D raised to the power n, they are in GP, right? So if you will see, I told you in the previous videos also of the GP that when the terms are in GP, so A, B, C, D, they are in GP in a sequence, right? First A, then B, then C, then D. So every three consecutive terms gives you something about GP. So what's that? If I will take that first three consecutive terms, A, comma B, comma C, I should know that whenever we have three consecutive terms of GP, the square of the middle one, that is equals to the product of the first and the third term. So product means multiply of the first and the third term. Okay, this we are getting from GP. Now why it happens so? If you will take a general GP, which is AR square, AR cube, and so on. Let's talk about the four terms only, starting four terms. Let's take any three consecutive term, any three consecutive term. If you will square the middle term, which is AR square, which is, if I will open it, it will be A square R square, right? Now, if you will see the first and the third term and you multiply them, you will get the same term as the value of the B square. So if you multiply A R square, that is equals to A square R square, which is equals to the square of B. So from the general GP only, we are getting this one. Also, if we will take the next three consecutive terms, B, C, D. So similarly, the square of the middle term, that is equals to the product of the first and the B and D, right? This we are getting. Also, one more thing from GP, whenever we have four consecutive terms, the multiply of first and the fourth term is equals to the multiply of the first and the second and the third term, right? That is the product of the extreme is equals to product of the mean. We can say that, but these are the things that we are getting from GP. Now, from this portion, I have get these things. Now, what we have to prove that these this comma this they are in GP. We have to prove them. Now to prove them that they are in GP, I know that the square, this is the first term, second term and third term, the square of the middle term is equals to the square of the product of the first and the third term. So let's talk about this. So we know that square of second term is equals to the product of first and third term. Okay, so we take LHS. So what is LHS? LHS is Bn plus Cn raised to the power, that is the whole square. Okay, now if I will open the whole square, we have an identity which is B square n a square plus B square plus 2ab. Okay, this is the identity. So if I want to open this one, so if you will see that I am taking B square inside the bracket and n outside. Same thing with c square. And I'm breaking this b raised to the power n, c raised to the power n plus b raised to the power c raised to the power n. I break this one. This value I brought as b raised to the power n, c raised to the power n plus b raised to the power n, c raised to the power. Now after that, what we have to do? Wait a minute. After that, what I have to do? If you will see what is b square. B square I got as AC. So if it will be AC raised to the power n, what is c square? I got from A, which is BD raised to the power n plus this one plus I am taking one BC common with raised to the power whole n, right? Now this is AN, C raised to the power n, B raised to the power n, D raised to the power n plus B raised to the power n, C raised to the power n as it is plus this. I will write BC is equals to what? AD. So I am writing as AD raised to the power n, and AD raised to the power n, I am again writing it as A raised to the power n and D raised to the power n. Okay, so this I got from LHS. Now let's talk about the RHS, which is the product of the first and the third term. Okay, let's do it very carefully. So let me rub the area because I don't have the space. So if you will see the product of the first and the third term. So this is the first term which is an. So this is RHS. An plus b raised to the power n multiply c raised to the power n plus d raised to the power. When I will open it, so I expand the bracket. So an multiply with c raised to the power n. So it is a raised to the power n, c raised to the power n. Then an multiply with d raised to the power n, a raised to the power n, d raised to the power n plus bn multiply with c raised to the power n. So b raised to the power n and c raised to the power n plus b raised to the power n multiply with d raised to the power n. So b raised to the power n and d raised to the power. If you will see the left hand side and the right hand side, so a raised to the power n and c raised to the power n, same. Then b raised to the power n, d raised to the power n, same value. Then b raised to the power n, c raised to the power n, same value. And a raised to the power n, d raised to the power, same value. It means if I got the left hand side is equals to right hand side, so we can say yes, the terms this, comma, this, comma, this, they are in GP because the square of the middle term that is coming equals to the product of the first and the third term, right? So yes, everyone, thank you so much. That's that.